Hi, my name is Christopher Crowley. I'm going to be presenting on the Cybersecurity Operations Center Technology Taxonomy, which I use as part of my consulting and instruction for cybersecurity operations centers. I'm going to start with my apply slide because I want you thinking about these things as I go through the material. Immediately, right now, in the chat window, as I'm going through the taxonomy, I'd be interested to hear if you think that I'm missing things or if you think that there are things that this is just too large of a taxonomy list. The technology that I'm going to go through is extensive and thorough. I would like you to consider that as a general guide for everybody in the world for their security operations centers as a reference of all the technology that we need in order to be able to do this. Then when you go back to work, I'd like you to crosswalk that listing with the things that you have. And I'll talk about how I would like you to assess the shortcomings that you might have in your environment. And then plan to acquire appropriate technology for your environment and then implement it in a good way. So let's start off with why I'm even doing this. I see a problem globally of selection of technology. And I'll talk about a couple of examples of this in a moment. What I have found is when helping people to build out their security operations centers is even if I go to a very large vendor who probably owns all the various technology that I'm going to talk to, I can't go to them and say, hey, I just want to buy the SOC package. Give me everything. Doesn't exist. And if you can provide that, I'd be interested to hear that, right? There are actually a lot of people in the world that look for something like that. Just give me the SOC package because I want to build a SOC. What I actually prefer doing, though, is starting with this long list of technology and then selecting the right thing for the organization. And hopefully this technology taxonomy is useful to you in doing that for your environment. There's also a lot of market information that's out there that is provided by vendors and analysis companies. These are good, but they're not really open listings of everything. They're usually focused on specific capabilities and specific technologies and then comparing the vendors within those specific technologies. So my view of the problem is that we need a solution, and this is a start of that solution. I want you to think about picking the technology for you. Now, the way that I do this and the way that I suggest that you do it for yourself is have a complete list and then get to that point of here are the things that we actually need. A lot of times people say to me, hey, Chris, what's the absolute minimum that a SOC needs in order to do the things that a cybersecurity operations center does? I don't take that approach. I say, here's all the stuff that we could use. What are your intentional functions? And then I say, here's the technology that we'll need in order to make those things happen. Now, you might also have constraints of budget. Most people who run SOCs have a constrained budget. You might also have constraints around open source. You can use it or your favorite. You might have specific vendors that are excluded from the selection that you can make because of import or export restrictions or government telling you can't use that particular software in this particular agency. Whatever it is, you have to then work around all that and try to glue all these technologies that you pick together. So in this listing, I am defining the boundary of the technology taxonomy for those things in order to run the security operations center. I'm not talking about all of your IT needs. I'm just talking about the cybersecurity operations center needs. So as an example of where that boundary exists, let's say you have an LDAP server for your authentication for all of your users. That's not really part of our infrastructure and the tools that we need, but we would need something to be able to monitor that authentication system. This might be LDAP. It might be a proprietary implementation of LDAP. So if you've got Active Directory, I don't expect your SOC to run the Active Directory. I expect your IT team to run that Active Directory, and then we instrument that Active Directory in order to see it. Okay, that would be part of our infrastructure components. Other things that I'm not going to talk about because I just really don't have time is how do I align people with the technology? What's the minimum that's absolutely necessary? How do I maintain this? Even though I'll mention the ideas of maintenance because I think that's an important aspect of procuring tools. I also won't talk about how I advocate use of use cases and hunting and training and all these other things that actually are important for a SOC. Just don't have time for it, okay? I have other resources out there online that you could look at in order to get the frame of where my thoughts are on those subjects. But for now, I'm really just trying to focus on technology. I'd also like to point out, and this is an excerpt from the 2020 SOC survey that I wrote, released it in December of 2020, basically a collection of questions. I asked about 30 or 40 different specific technology types. I said, do you use this technology in your SOC? And I also asked, do you have this fully implemented in your environment? And if you have it purchased, have you not even yet implemented it? Okay, and so these sorts of questions are insightful. And something that I find that we do as a global cybersecurity community is we tend to buy tools and then don't even implement them. That's unfortunate. And I think that the reason why that happens is because we are inclined to buy the latest and greatest thing rather than thinking about our technology portfolio as a cohesive set of tools to accomplish specific objectives. So the first time I tried to do this, I actually mapped technology to the NIST cybersecurity framework. If you're not familiar with the NIST cybersecurity framework, it's really a phenomenal framework to think about in terms of how you do cybersecurity operations. They talk about identify, protect, detect, respond, and recover. And so what I did was I took this and then I took the technology list that I had at the time. This was actually part of the 2018 SANS SOC survey that John Pescator and I co-authored. This was an attempt to help to make it easier for people to answer the questions about the technology that they used. It actually didn't work great. It was a noble experiment, as it were. And what I found was actually, if I looked at the categories and then where the technology was, almost all of the technology was in the protect and detect. So I also want to sort of frame this conversation about what I think a security operations center needs to do. And I discuss this in the context of functional areas. Okay, so for SOC functional areas, I consider a steering committee. This is where your customers, I actually use the term constituents. These are the people who you're supposed to be defending. Those people and their information systems are what you're supposed to defend. And the steering committee helps you to understand what their needs are. It helps them to have a venue to provide feedback to your SOC. It also helps your SOC to be able to communicate to those constituents to tell them about the threat landscape as you see it, to provide metrics and other sort of communication from the SOC. So that's sort of exterior, but a necessary functional capability for security operations. Similarly, the command center is an interchange, sort of more of a technical and tactical interchange from the SOC to its constituents. The command center in my functional area model is actually intended to provide guidance for the operations of the internal functions of the SOC. It also helps to prevent them from being interrupted by people asking for information. Monitoring is identifying that we have problems. Threat intelligence is tracking and understanding the adversaries who are attacking us. Incident handling is dealing with problems when they come up. Forensics is deep dive, authoritative technical analysis of the information assets which we're investigating at any given time. And self-assessment is things like baseline creation, vulnerability management, penetration testing, and the development of exercises, both for our SOC staff and for the constituents in order to make them as effective as they can possibly be. Now, part of this then becomes a question for you probably of, well, I've got 3 people. How do you expect them to do all these things? Or I've got 150 full-time staff. We don't organize them that way. That's okay. I discuss this in terms of functional models in order to talk about all the things that I think security operations needs to be. And if I'm telling you a list of technology, I should be providing you at least with a backdrop of what I expect that technology to be used for. So if you've completely outsourced incident handling to some third party, well, you probably can exclude some of the technology items that I specify. So this is another aspect of all of this tech is how do I then interact with my managed security service provider they're running one SIEM and I'm running a different SIEM, or how do I decide this? I'm not really going to solve that for you now, but I am going to give you some ideas about how I've seen people implement technology in coordination with managed security service providers. The short story is maybe you have technology that you really like and you're looking for a security provider. And part of the request that you make to those security providers is, we use this SIEM, you need to be able to use it too. We're going to have this on-premises SIEM and you're going to monitor those things. Maybe you're out shopping for a service provider and they are able to specify the technology that they want to use, and then you'll implement that in your environment. So you have to decide what the right approach is for you in that context. So let me get into the definition of the categories. This is a number of categories with subcategories and with specific technologies inside of each subcategory. Now, I don't actually have the time to go into it here, but I actually additionally have a list of example technologies inside of each of the technology types which I'll cite. There's a lot of information that I've collected on this over the years. I find it to be very useful. I don't mean to specifically endorse any vendors, and I'm going to really try to avoid specifying any vendor names here because that's not the point of today's talk. So I'm going to get into these now. The first category is visibility. Visibility in the context of external awareness. My SOC needs to be aware of the things that are happening out there. And so this includes threat intelligence portals, the way that we ingest information. And so we might have a data feed that we're ingesting related to threat information. We might also use that technology or a different one where if we're capable and mature enough to be able to produce threat intelligence, we're then disseminating that information to our partners who we've agreed to share threat intelligence with. We have ways to track globally on all of the different threats that are changing in the environment. We have some sort of indicator of compromise portal where we can look for stuff that we've encountered previously. We can also use some sort of a portal in order to correlate from an IP address to a host name or an internet service provider. All these things are part of our portal that allows us to understand information about our threats. We also want to have some sort of operational status tracking. And this is operational status of the information systems which we're supposed to be defending. If that system's down, we should know about it. If that system's performing poorly, we should know about it. And we should be able to use that information to help to inform our security-related insights. Similarly, the global stage that is unfolding at all times also affects our cybersecurity concerns. It infects them too, right? So that global stage is something that my Security Operations Center should be aware of. And you might have a feed of news information relevant to your market sector, to the regions that you operate in. And this is not about cybersecurity at all, just the real world. I mean, we're part of the real world too, but the other things that are happening in the world that are not specifically relevant to cyber. Another part of this is the weather. As the weather changes, we have impact in cybersecurity, right? Tornadoes and hurricanes and tsunamis and other things that actually are affecting the operational environments that we're intending to defend. Related to this is what I call the internet weather, as undersea cables get cut and DNS hosting environments get affected or taken down, or BGP routes are published that reroute traffic from one place where it should be to another place where it shouldn't be. Oops, sorry, that was a mistake, they said. But this is the sort of thing that we should be aware of, and we need a way that we can maintain that visibility from within our SOC. Another aspect of technology that we need is the ability to communicate. In communications, we use telephones, right? This is cellular service and, sort of our commodity telephone lines, maybe VoIP, however you've decided to solve that problem. Additionally, in our communications, we probably want to have some sort of way to maintain a connection between our staff inside of the SOC. This is chat and email and file sharing, collaboration platforms. We might have an authoritative knowledge management portal where we share information internally among our staff. If those communication capabilities aren't already encrypted, well, you probably are going to need to select some technology to overlay on top of that to provide end-to-end encryption and protection of the confidentiality and integrity of that information. Similarly, you need to communicate with the people who you're protecting. And some of this might be public, and so you have a website where they can browse to, and some of it might be part of your constituent delivery of information. This might be metrics or the tickets that they're working on, service level objective tracking, the status of the SOC. If you're operating at a diminished status, I wouldn't really want to share that publicly, but I would want to inform my constituents about it. Another aspect of our technology portfolio is the operations. This is something that a lot of people just think is the only aspect of the SOC, but I disagree with that. I think it's actually a larger portfolio that we need to consider. So the orchestration and automation, this is a category of tools which is actually stands on its own. This is the glue in many cases that allows us to make multiple different systems coordinate with one another. That's kind of the definition of orchestration. Automation is, do these tasks, computer. I want to have it done repeatedly with high precision on an ongoing basis. Ticket tracking is another thing that helps us to manage our work and our workflow. And there are a lot of different vendors out there that sell ticket tracking systems, and everybody has one. This is something that the correlation to the owner is actually a tool that we can use in order to track who is assigned a specific asset. We can also track who is responsible for a specific asset. That responsibility allows us to understand who we're supposed to inform when there's a problem with that asset. It might also tell the SOC what they're allowed to do or not allowed to do on a given technology at a specific moment in time based on what owner exists for that information asset. And since we're talking about operations, part of the stance that I hold about Security Operations Center is that you should have at least as good of a DevSecOps process for your own tools as the IT teams who you're intended to protect. Otherwise, if you can't keep up with them in that regard, you are going to risk not being able to defend those information systems. So you're probably going to need tiers across all of these important systems in order to be able to test before you push things to production. The detection and protection tools are organized in this taxonomy in terms of what it protects or detects on. And so the first category of this is the endpoint. If you're doing forensics, you would need ways to be able to extract information from those hosts that you're responsible for protecting. You might call this a HIDS tool or a HIPS tool or an endpoint detection and response tool or an endpoint protection platform or a malware protection system. I kind of don't care what you call it, but I need something which is on that system, which is an overlay of the standard processing of that system in order to protect it from malicious code and to help us to understand when malicious code runs, especially in cases where we're not exactly sure that it's malicious and we need to be able to then investigate it after the fact. I also need ways to collect memory. This is part of my acquisition of assets. I would like to be able to do that remotely from the comfort of my analyst's workstation, but sometimes that doesn't work. Maybe I don't have the instrumentation. Maybe I don't have the network access. Maybe I'm moving across satellite uplink, and I'm not going to move a 2 terabyte extraction of some information off of that host when I'm doing a host-based file system and memory collection, right? So these sorts of things, I have remote ways to do this. I might also need to have a local collection mechanism for this. I might have user behavior analytics tool. I need to be able to collect from my mobile devices. If I'm dealing with encrypted platforms, I probably need some way to escrow the keys in advance of using encryption keys on those endpoints in order to be able to read the data if I do a full device collection from that host that I'm trying to investigate. Similarly, on all my network assets, I tend to have some sort of network instrumentation with a network intrusion detection and a network intrusion protection tool. I will collect my logs across all of my network assets, and I might have a lot of different types of applications that actually run on my network that I need a way to instrument. Maybe you have full PCAP. If you do have full PCAP, I hope you also have TLS intercept. In terms of the infrastructure, all of the stuff that allows us to run our network needs to be instrumented for our SOC. If you haven't thought about e-discovery, please Think about that. If some other team inside of your environment is already making e-discovery happen, I wouldn't try to pull it into my SOC, but I will advise you that if your organization is asked to do some form of e-discovery, it's coming to the SOC to say, hey, can you go find these things for us? Okay, so having a technical implementation of this in advance is actually a really good idea. All of our logs on our user activity, we can collect that as part of our infrastructure. Our Wi-Fi systems also useful in terms of instrumentation to understand what's happening in our environment. Our malware detonation devices. Some people call this a automated sandbox. The idea of this is that we're able to instrument by running and opening documents, running executables, and seeing what happens in order to make a cybersecurity assessment of those things that are coming into our network. So we might have a portion that you call the cloud. I call it your extra structure, because there are a lot of things that are actually part of your infrastructure which you don't own and manage and control. And so cloud is a nice term for that. I think extra structure is more precise because there are a lot of things which actually aren't part of the cloud. So we need to be able to instrument those systems to do extraction of information for our analysis within our SOC. We might be using data tokenization tools wherein we put representations of data in cloud storage. And then when someone wants to actually see the real data behind that, it actually looks it up in the token server. And if the system that's requesting the real data is vetted, then the user is allowed to see that data. And across all this, for our detection and ultimate prevention, we want to be able to correlate these various data elements in order to understand that maybe we have a problem. And we typically use a SIEM in order to do this. The security incident and event management is really good at doing correlation, but it's not the only tool that can do correlation, right? So we might have an engine that just does log correlation and stitches things together for us. We might have a tool which is really good at doing historical analysis with new indicators of compromise that we just learned about. Right, so this is rapid searching across massive volumes of technology. It's not really a SIEM, but it is a specific search tool that allows us to look for cybersecurity issues. With all this data that we need to actually investigate, we need ways to be able to store that for the long term. One aspect of this is the idea of aggregation. And there may be certain data which references specific types of information that your organization needs to store or label in precise ways. There are usually legal statutes which require that you protect, say, a personally identifiable information in a specific way. And there are various legal terms for this across the globe that you need to be aware of. If this is financial information, if this is information about a specific individual, you need to protect that appropriately. And part of your security portfolio might be appropriately labeling where that data lives so that the security controls are matched to the type of data that's stored on your information systems. You might also have to archive these things for a certain amount of time because there are legal requirements to do this. Archive is the standard sort of retention of data, but then retention requirements, you might have specific cases where you need to store something for longer. And the security operations might be responsible for doing that. And in that sort of case, we're asked to store a file system image or a log entry or a log file for an extended period of time. Where you store that is something that you should consider and have protection for those storage things. Since all of this is a physical construct, ultimately, we then need physical controls around where we're storing our data. These might be rooms that we have a key to. These might also be safes within our office, or the office might be in a safe, right? Or a safe. I've actually worked in some offices which to get in the door, you have to know the code on a very complicated safe, and that office is effectively a vault in its entirety. Not a fun place to work, but places where I've worked in the past, right? So this sort of physical control is important depending upon the sort of information that you're protecting. As part of your information protection portfolio, you also need to be able to destroy information, right? So the ultimate destruction of an information asset is usually the security team's responsibility. Next, top level category is the idea of deception technology. This is cool, I think. I think it's kind of a thing that a lot of people don't consider this as a viable technology, but a lot of vendors recently have been working in this space because with deception, we tip the advantage in our favor in terms of access to assets. So internet connectivity is an example of this. If I want to interact with a threat, I should not be necessarily divulging that that's coming from my actual network. In order to do this effectively, I might also create some personas. Now, this might be associated with my business. And when I go to interact with an adversary controlled asset, I have a specific email address that I use in order to sign up for the whatever, rather than my actual email address. Right? So these sorts of personas, if this is an email address that the attackers can't find anywhere online, they might not send the attack. So this is a part of deception, is management of personas, having research networks to do this, and networks where we can actually do testing and modeling. Having a scale model of the internet is actually a good idea if you're doing advanced deception type work. You might do automated network quarantine, wherein a system which wants to connect to your computer network is actually going to be interrogated prior to being allowed on the real network. Right? This sort of automated quarantine has been around for a while, but it's actually an aspect of deception. Another way that we could use this exact same technology is when we have a host which we're suspicious of after it's been allowed in, we can actually flip it into a quarantine subnet for some period of time. It would be great if that quarantine subnet looks exactly like our real network. And then we can actually watch the system in isolation to see if it is in fact a problem or not. We can deploy this in terms of honey tokens. The idea of a honey token is the stuff that an adversary would typically collect in our environment. Just give it to them. Now, the point of that is that it actually makes it so that it's easier for us to detect the reuse of this. As an example, if you're suspicious of employees taking intellectual property and sharing it with other places, you could embed inside of the files which contain your intellectual property unique tokens. And those unique tokens could then fingerprint back to who took that intellectual property and then shared it. Maybe they didn't share it on purpose. Maybe they were compromised. Maybe their home system was compromised where that information was actually stored. So this sort of honey token is useful for our long-term tracking. If you look at the industry and the news associated with large-scale breaches, there is almost always some aspect of credential reuse. Guess what? Give them credentials to use and then detect them. Don't give them credentials that get them into good stuff. Give them credentials that make it easy for you to identify that it's an adversary using that. Go pre-populate the have I been pwned space with fake tokens and see if people try to log in with them. Right? And you could actually also have high interaction honeypots and low interaction honeypots with a system that the attacker is actually going to interact with, and then you can monitor that. From an analysis perspective, we need tools to help us to model and test what we're dealing with. We need spaces where we can develop new rules for our endpoint systems and our network detection systems in our SIEM. We should also be able to track change in the IT systems, and we typically call this change control. Now, you might have good baselines. I hope you do. But the idea of baselining a system, we also need technology to be able to do that effectively and then track the changes to our baselines over time. We also want to be able to do analysis of the indicators that we have. And you might not like the IOC term, that's kind of fallen out of vogue here recently. So whatever you call it in terms of specific elements of data related to things that attackers are doing, as you build those indicators, as you develop them, you should have a way that you actually do that regularly. And this tends to be done on some sort of an isolated workstation. So isolated workstations for threat intelligence production, isolated workstations for forensic analysis, high performance workstations which have lots of RAM and lots of hard drive space and the ability to process lots of data simultaneously with software, which is specifically intended to do that processing. We also have vulnerability management platforms where we can do remediation tracking and scanning of vulnerabilities within our environment. As we deal with code quite frequently, we want to have disassemblers and debuggers and other tools of that sort in order to allow us to understand what can that program do from a static analysis perspective. We might have simulators for our staff in order to train them. We might also have simulators that we use in order to assess and train our employees or our constituents as well. So I hope you got all that. That's the technology taxonomy. If you have thoughts on that, hopefully you've been typing them in the chat window while I've been going, but if you have thoughts on that of, Chris, there's no way that we could ever buy all of this stuff. Okay, I understand it, but I'm not going to sell you short by giving you the short list. And then you come back and say, oh, well, you forgot about all these other things. And if I forgot about something, please put it in the chat window. So the technology thoughts that I have at this point. First of all, your cybersecurity operations center is the defense of the information assets. And if your SOC does not have the same level of confidentiality, integrity, and availability protections of the systems that it's intended to defend, you might encounter a problem. If your adversary realizes that your SOC systems are vulnerable, a clever adversary would go ahead and modify those systems so you're flying blind, but you're not even aware of it. A less clever adversary would just knock those SOC systems out while they wanted to attack so that you were aware that you were blind at that time. In terms of system administration, you have to figure out who's going to take care of all these tools. I mean, if I'm asking you for good availability, integrity, and confidentiality, that means solid systems administration. I'm not going to go too far down the rabbit hole of this, but I do want to say that a trend that I've noticed is that a lot of people are outsourcing this because it's so hard to do effectively and it is so expensive for many organizations. Similarly, and I mentioned this early on, is that we need some sort of a glue to stitch the information together between all of our disparate systems. Now, these systems all have data, and I want to be able to collect that data into one central environment. Or if I can't do that, I want to be able to go get that data on an as-needed basis. I want to be able to make configuration changes rapidly, right? And I'd like to automate a lot of that stuff. So the ability to integrate between disparate systems has frequently been the area of actual scripting. And so scripting is a good way to do that. You might also then hire professional services to help you with this. You might lock yourself in by saying, we've decided on this particular SIM, and we will only use tools which effectively integrate with that SIM or this ticketing system or that network IDS or this endpoint protection. It doesn't matter how you lock yourself in, but we actually decide to do this frequently. And then the last thing, and I know it's a bit of a buzzword, but the SOAR tools are actually intended to solve this problem. And they're like scripting with what you see is what you get overlay on top of it with a whole bunch of standard plays already built for you. And of course, now you need to decide, hey, where am I going to host all this stuff? So various locations globally, you might need to buy 10 of these and deploy them all over the place. You also need to consider if you're going to share your your tools with your IT teams, right? Your technology is actually probably really useful to them, and you expect them to give them their data to you. You might also consider sharing your tools with them. So how do you use this? One thing that I'd like you to consider doing is be skeptical of your own confidence in knowing all the tools that are actually in your SOC. You might know them all. Does everybody in your SOC know this? And so I have some videos about how I advocate for hunting. And the first thing that I suggest as a hunt is to hunt your own tools. And so this actually drives the notion of hunting as a skeptical and creative practice. It also is intended to get everybody on the same page to understand that this is what we do for hunting. And hunting your own tools, I should have everybody come up with the same results and have that be 100% across everybody agreeing on the hunt. So after you've done that and gotten to some sense of agreement across all your staff, I would like you to take this taxonomy, modify it to suit your purposes, or just start with the whole list, and then say, we should get a tool because we do this thing all the time, and this particular tool would make us more efficient in doing that thing. Right? That's a great selection criteria for technology. Similarly, you can actually take the MITRE ATT&CK framework, do a defensive gap analysis on those things where you're confident in being able to do detection, crosswalk it with what the MITRE ATT&CK framework says about specific threat actors who are targeting people and organizations in your industry, and then use the MITRE evaluations, which cites which tools are effective at specific behaviors, and then select technology based on that. It's a great way to use this taxonomy, right? The combination of the MITRE ATT&CK evaluations with a long list of specific technologies and the vendor information associated with that, that's a great approach to this. And some of you might actually have a consideration where you can say, you know what? He says, this is all the stuff. We've got 80% of that. Let's just go buy it. And there are actually some SOCs in the world that will do that. Now, I don't think that that's the best approach, but if you're that big of a security operations center, having one of everything is actually not an unreasonable idea, because there might be a specific instance where a given technology is perfect for that particular case. And one other thing about technology, it's all broken. It all falls apart in given circumstances. Much of it is vulnerable in ways that we don't yet understand. So having a backup tool is actually a pretty good plan. Having a plan is what I really want you to have. This long list is intended to help you to facilitate building a plan. Okay? There are amazing tools that are out there, astounding tools that do incredible things. But there's a global scourge of partially deployed tools, right? Tools purchased without actually ever getting implemented. That's kind of sad, really. And so what I would like you to do to take away from this talk is to basically think about your strategic vision of those things that you want to deploy in your environment and how you're going to do it. So I'll remind you of the action items right now. Put it in the chat window. If you can remember all the things that I said, what did I miss? Right? That'd be great. I'd love to hear that. I'll just absorb it into the taxonomy and move forward and share it with other people in an updated version. If you want to have credit, I'll include that. If you think this list is too long, tell me why. I'm curious. Right? This is something that I've abstracted across years of work. And if you think that I'm wrong with this approach, I would actually love to hear that criticism. I would then like you to take this and consider, is this the right list for me? I actually have a spreadsheet that I share publicly for this list, right? And you can take it and adapt it to your needs. So I'd like you to start with what's right for me and the functions that I actually need to perform. And then I want you to take that list of shortcomings and use a threat intelligence informed criteria for selecting what technology will solve problems for you. These might be efficiency problems. These might be problems that you think, you know what? No technology will solve this for me. I don't need technology to solve these problems, but I do have some technology that'll solve those coverage problems. And then I want you to, going forward, buy your tools in a way where you really understand how you're going to deploy that on the systems where it matters. And so with that, I want to thank you for your time.